Welcome to the Backyard Professor Math Videos. I'm Kerry Shorts, the Backyard Professor. I want to do kind of a wrap up with fractions on doing a few mixed numbers, and then I'll mix up various different kinds of fractions, and we'll use this as the kind of sum up, wrap up of fractions. Unless there's something you don't think you got good enough at, let me know, and I'll do a practice video with those kind of fractions with you, I promise. And then I'll review all the rules on fractions. And I'm just popping these out of my head because that's how easy fractions are. You don't need to have an answer book. You don't need to have a teacher telling you or whatever. You can invent your own and practice all day long until you get absolutely perfect with these. 3 1/3. Say plus 2 1/9. And you say, I haven't got a clue what to do. That's right, you don't. But you're wrong, you do. Remember, we turn mixed, now when I say a mixed number, I mean there's a whole number and a fraction together. A whole number and a fraction together, right? We can convert these into mixed, improper fractions, and then find the common denominator and then solve it. So let's do that here. 2 times 3, we multiply by the denominator, this is 6, and then we add the numerator, plus 1 is 7 2s. Plus, we go 9 times 2 is 18, plus 1 is 19, 19 9s. Now we are with addition, so we have to have the common denominator. With adding and subtracting fractions, we have to have the common denominator. So we look for it. 2 won't go into 9, so what will 9 go into next? 18. 2 goes into 18, right? How do we get 2 to 18? 7 over 2, how do we get that to 18? We multiply it by 9. What is that showing? Doggone camera, stay still, dude. Man, I hate it when cameras disobey me. 2 into 18 is 9. 9 times 7 is 63. There's our first fraction. Then how do you get 19 9s to 18? 19 9s, getting 9 to 18. You multiply it by 2. 9 times 2 is 18. So you take that 2 and multiply it by 19. What's 19 times 2? 38. So there's our 2 fractions. I'll put these up here. Boy, I'm running out of room. I'm trying to write large so it's easy for you to see. 63 18s and 38 18s. Boy, you can see this is going to be a whopper of an improper fraction, can't you? 63 and 38 is what? 101 18s. Okay? How many times does 18 go into 101? Well, 5 20s is 100, so I would imagine 5 18s would do it, right? 5 18s is what, 90? Or 9, 90, 9? Yeah, 18 times 5 is 90, so it goes into 101 5 times. Oh boy, I really about schmucked up that one. And what's the remainder? If 18 times 5 is 90, what's the difference now between 90 and 101? 11, right? So that's your numerator, and then you carry back the denominator, the original denominator you had, 18. So, the improper fraction, these 2 mixed numbers added together with being put into improper fractions end up as 5 and 11 18ths. So that's how improper fractions and mixed numerals work together, right? I'm going to see if I can try to write smaller so I don't have to erase so much. Let's do another one. I'm going to try to keep them simple. I mean, seriously, we will run into, and I don't have my calculator with me, so I don't want to take the time to calculate it out because I have so much I want to do. Sometimes I'll pre-write these problems out so I can show you more of them, right? Because you're here to learn math, right? But 303 47 963rds plus 273 165ths. We are going to be dealing with problems like this, and they're easy. I promise. All it takes is practice. I'm serious. I will show you shortcuts all over the place as we develop. Right now, we build the foundation because we master math. Math does not master us, does not master you. All right, let's go. 2 1/4 times 2/3. And you say, no, wait a minute, can you take a mixed number and multiply it with a fraction? Absolutely. Remember, every whole number, 1, 8, 16, 59, every whole number is also a rational number. Now, rational numbers are those numbers that can be put in fractions with the numerator and denominator. But every whole number is really a fraction, right? 1 is 1 over 1. 8 is 8 over 1. 16 is 16 over 1. 59 is 59 over 1. All that's telling you is, if you take the denominator and multiply it into 59, 1 goes into 59 how many times? 59, right? So that's the idea. We just make an improper fraction to multiply. Now, we don't have to worry about common denominators like we do in adding and subtracting, because this is multiplication. But we do want to do this into an improper fraction. This is one of those instances, did I not tell you, that it's easier to turn the number into a fraction in order to solve this problem? Right? Isn't that cool? Watch. 2 times 4, we multiply the whole number by the denominator, and then we add the numerator, plus 1. 2 times 4 is 8, plus 1 equals 9/4. Right? And now we get to multiply by 2/3. Now check this. But I'm truly serious. This just worked out by pure luck. I'm really glad I did this one, though. I did not have this pre-thought out. I ain't that smart, man. I've only got 3 good brain cells left. We can reduce this right now before we multiply. Watch this. 2 is a factor 4. Remember, we cross multiply in an X shape when we're multiplying to reduce. If you can reduce, you want to. 2 goes into 4. Well, 2 goes into 2 once. You slash that out and leave a 1. And 2 goes into 4 twice. 2 times 2 is 4. If you take out a 2, you leave a 2. So that goes to 2. 3 is a factor of 9. So we can reduce this. 3 goes into 3 1 time. 3 goes into 9 3 times. Now we have a piece of cake. 3 times 1 is 3. 2 times 1 is 2. This is 3 2's. Now this is a beautiful case for me to show you an illustration here. Just bear with me for a minute. I'm going to illustrate something cool. We have 3 2's. Now what does 2/3 tell you? 2/3 is if you had a pie, 3 parts. the denominator is the whole pie. There are 3 pieces of the pie. 2/3 says you take 2/3. So you take this piece and you take this piece. 2 of the 3, right? But our number here is 3/2. And what that's telling you is we have a whole that is divided by half, and we have another half. We have 1 1/2. More than 1. The denominator is bigger, so it's bigger than 1. So 2 goes into 3 one time. The difference between 3 and 2 is 1. That's your numerator. And you keep the denominator 1 1/2. 1 whole pie and another half. That's how that works. Isn't that fun? It's fun to see an illustration like that. It's fun to see math illustrated. We'll be doing a lot of graphs also, because the more we can illustrate things, the easier it is to comprehend them. Now let's do, let's keep this easy again. 1 1/5 times 3 6/7. We're doing multiplication, so we don't have to worry about a common denominator. Addition and subtraction, you have to do a common denominator. Multiplication and division, you don't. In this instance, I'll show you another secret. We can turn these into improper fractions. 5 times 1 is 5, plus 1 is 6/5. 7 times 3 is 21, plus 6 is 27/7. We can do it that way, but there's another way. And the more ways we have of learning how to do these, the more powerful we get. This is the beautiful consistency and beauty of math that I am growing to appreciate the more I do math. We have a whole number and a fraction together in a mixed number. We're multiplying this by another whole number and a fraction together, right? Let's separate the whole numbers. Let's take 1 times 3, right? And let's separate them out. Now you want to put them in parentheses. Parentheses will become our best friends. I so promise. We will use parentheses because they clarify and they keep things in great order. I promise, you'll see. Now this just leaves us the fraction, right? 1/5 times 6/7. And now you have 6/35. Can this reduce? 35 is 7 times 5. 6 is 2 times 3. So there's no common factors, so that won't reduce. So our fraction is 6/35. Add that to 3 times 1. You have 3 and 6/35. Okay, let me just do some mix-up fractions for you. Okay, let's do 5/6 plus 7/8. We haven't done something like that. You can't always have ones in the numerators, right? Sometimes fractions can get sloppy and messy. We are in addition here, so we have to get a common denominator. 8 times 2 is 16. 6 times 3 is 18. That won't work. 8 times 3 is 24, and 6 times 4 goes to 24. So to get to 6 to 24, we have to multiply by 4. 4 times 5 is 20. And to get 8 to 24, we have to multiply by 3. 8 times 3 is 24, so 3 times 7 is 21/24. And 20/24 and 21/24 is 41/24. And there is our answer, but it is in an improper fraction. We can leave that. I'm going to. It's okay. What if we do 7/8 minus, say, 2/5? Now we're in a subtraction, so we want to do a common denominator, right? 8 times 5 is 40. Is there a lower common denominator besides that? 2/8 are 16. 5 won't go into 16. 3/8 are 24. 4/8 are 32. 5/8 are 40. So 40 it is. Now watch how easy this will become as you practice fractions. I'm not trying to go too fast, I just want to show you the capability that you can develop. 8 goes into 45, so this is going to be 35 40ths. Right? 5 goes into 40 8 times, so this is going to be 16 40ths. Do you see how I did that? And that's going to be minus. Do you see how I did that? 7/8. How do you take it to 40? You multiply it by 5. 8 times 5 is 40. You multiply the 7 by 5, and there's your 35 40ths. 35 40ths. See, you can get to where you can truly do this stuff in your head once you learn enough and practice enough. I suggest you don't do that too much, though. Do it step by step, and that's a lot closer to bulletproof because you can misadd, right? So anyway, there it is. 35 minus 16 is what? 19 40ths. And there's your answer from the subtraction. Let's here's one. Now, another area in algebra that people do not like is the word problems. And I will take the complete fear out of you of word problems too, and the frustration. The key with word problem is learning how to translate the English into math, right? We will get to those in a while. After these fractions, I want to do positive and negative numbers in the number line. I want to show you some really great ideas on those. But let's do a word problem with fractions right now in real life that happens, just to show you how applicable algebra and fractions are. I mean, yeah, we know that intellectually, but let's do it mathematically. It's easy. Let's say you have a 7.5-inch pipe. You have to cut it into 3 even pieces to fix your kitchen sink, but you need 3 equal lengths. How do you do that? You take 7.5-inch pipe and you divide by 3 because you need 3 of them. Here's your pipe. You need 3 even pieces, right? So you've got to cut them exact. How do we do that? You take 7.5 and divide by 3. Now look at this. That doesn't look too easy, right? Here's where making fractions helps you solve the problem. Remember what I told you about whole numbers? Every whole number is a fraction. So let's make that 3 a fraction. How do we do that? 3/1. You can do that with any number under the sun. Now look, we're beginning to get fractions together, but this is still a mixed number. Let's make that an improper fraction. How do we do that? 7 times 2 plus the numerator plus 1. So this is 14 plus 1 is 15 2s. We have 15 2s divided by 3 1s. Or to put it in a stack form, 15 2s divided by 3/1. Do you remember how to divide fractions? You flip the second one over upside down and multiply it. So let's flip this over. 15 2s times 1/3. And look at this. 3 is a factor of 15. So 3, we can slash this down. 3 will go into 3 once. 3 will go into 15 5 times. We multiply it straight out across. 5 times 1 is 5. And 2. It's an improper fraction. So we ask ourselves, how does this help us solve our problem of our pipe? Real easy. How many times does 2 go into 5? Twice. 2 times 2 is 4, right? So we have 2. What's the difference between 5 and 4? 1. Keep the denominator. There we go. A 7.5-inch pipe you need to fix your kitchen sink. You need to cut in 3 even, same length pieces. They'll be 2.5 inches each. Now see, you just make something up like that, right? To practice. You can make up your own word problems. You can use the fractions that we're learning and see how it directly applies. That rocks! I can't help it. That's cool. Math is relevant. Math is seriously relevant. It works. It works. It's real. It's fun and it's easy. I haven't killed all 3 of my brain cells yet doing any of this, you guys. 1/3 divided by 4/9. You flip that around so that it's 1/3 times 9/4, right? Then you multiply across. 9/12. Now I didn't reduce. So I have 9/12. Now I have to reduce. 3 is a factor of both 9 and 12. So I take a 3 out of it. Take a 3 out of 9, it leaves me 3. I take a 3 out of 12, it leaves me 4. 3/4 is my answer. Of a division sign, 1/3 divided by 4/9 is 3/4. It's that easy. What if we did 2/5 divided by 3/8? You say that's too difficult. No, it's not. Flip the 3/8 over and multiply. 2/5 times 8/3. 16/15. Whoops. You got to write the right number down. 16/15. It is an improper fraction. The numerator is bigger than the denominator. So you divide 15 into 16. Gives you 1. 1 left over is your numerator. It's 1 1/16. It's that easy. You don't believe me, do you? Fine, let's do another one. Let's do a... oh, hey! Here's what we'll do. Let's do a 1/2 by 2/3 times 2/3 times 3/7. 3 different fractions multiplying. How the heck do you do this? One step at a time is how you do it. You go 1 times 2 is 2. 2 times 3 is 6. 2 times 3 is 6. 6 times 7 is 42. Now 6 is a factor of 42. So 6 will go into 42 7 times, right? So 6 will go into 6 once, and it'll go into 42 7. So that reduces down to 1/7. Piece of cake, man. What if you had this? What if you had this with addition? Now here's where you can start playing with mathematics. We've seen it with multiplication. Now let's do it with addition. Right? Let's do 1/2 plus 2/3 plus 3/7. Now we can begin to see the difference as we do this. We know now we're adding, so we have to do a common denominator. What's the common denominator of all these? Is it 14? No, 3 won't go into 14. Is it 21? No, 2 won't go into 21. Is it 28? 6, 7 times 3, 8 times 3 is 24. 9 times 3 is 27. It's not 28. Is it 35? It's not 35. What the heck's the common denominator? What you do is you multiply 7 times 3 times 2 to get to 42, and that's the common denominator. So, 42, 2 into 42, I'm going to try to do this quick in my head to see if I can do this right. 2 into 42 is going to be 21. 21 times 1 is 21 42s, which is basically 1/2. 3 into 42 is 14, right? 23 times 42 is 14, and 14 times 2 is 28. So we got 28 42s, plus 7 into 42 is 6. 6 times 3 is 18 42s. And now we can just add straight across the board. 28 and 21 is 49, 59, 69, 68, 67. That's 67 42s. It's an improper fraction, so we divide the 42 into the 67, which will go just once, as we know. The difference between 42 and 67 is 15. And there's your 42s. 1542. I think that's right, isn't it? 52, 62. Nope. I lied. It's 25. 1 and 25 42s. It's that simple, you guys. It is so simple, it's as easy as falling off a log. So that's what I'm going to show you with fractions. The next video I want to try to do is going to be, we're going to get very visual with the number line because it is a superb help with understanding how to do positive and negative numbers. And I promise you, as we get visual, I'm going to burn this into your brain to get visual in one dimension with the number line, because when we get to the Cartesian coordinate system with the two-dimensional, you are going to love me for showing you how to think visually. So, that's my video. Thanks for watching my video. Have a great life. Happy calculating. And I will see you in the next video. Come with your pencil sharpened and your bowl of popcorn. One of these days I'm going to fool you guys. I'm going to eat the popcorn while I'm doing the math, just to show you it can be done. Yes, we men can multitask. Kinda. Shut up and go to bed, shirts. See ya.